Hello everyone, welcome back. So in today's video we're going to talk about perspective and the cone of vision and what to think about when you're trying to create mainly like 90-degree angles. Like a lot of times when people start drawing perspective, they just throw vanishing points in there randomly and they don't really understand maybe where they're putting them or why they put them in a certain place, because when we draw in perspective, we have the ability to break all the rules. So that obviously gives us a lot of room for creating whatever we want, but also maybe getting some undesirable effects. So let's talk a little bit about that. So first, you generally start with a horizon line. Okay, that's where you are eye level in the scene. Anything above that, you're going to be looking up under those structures or whatever they are. Looking down, anything below that line, you're going to be looking at the top of those structures or whatever you're illustrating, people, whatever. So we start with the horizon line, and from there we want to designate a station point. So a station point in the CVP is actually center vanishing point, is really the point. I've heard this referred to as the distance that we are away from the scene. And mainly you just have to designate this regardless, because say you're not drawing something where you can see everything around it and work off an idea of like a cityscape or something like that. Maybe you're out in maybe you're out in space, right? So you have to be able to illustrate scenes that don't have anything to kind of hinge upon. And so this is where a station point is important. So you draw a line down and you designate your station point. Okay, from there you want to find your cone of vision. So our cone of vision is 60 degrees, and basically if you were to picture when you look out and you put your arms out and you put them to your side, you can barely see them. You kind of get like a faint view of your arms, and as you bring those further in, you start to be able to see those, right? So that's kind of the idea of cone of vision. So it's a 60-degree cone from the point of our vision outward, and so to find that, you're gonna use like a protractor, and you're going to figure out where the degrees are, right? The 60 degrees, 30 on each side of that station point or that center line of focus, just an orientation in the scene really, because this can be to the left or to the right of your picture plane, which we'll talk about here in a second. But you first want to find that angle. So you're going to go 30 degrees each side of this line will give you a 60-degree cone of vision, and you're going to establish that with a circle, because obviously we know the bottom of a cone is a circle, right? So you're the other end of this cone, basically your eyes. So there's your cone of vision. Now you can put your picture plane in that cone of vision, and the picture plane can be kind of thought of as your canvas. A really good way to think about this is like you're holding up a piece of glass, and all the 3D information that you can see through the glass is being captured on the 2D glass. And that's really what you're illustrating. You're illustrating a representation, a 2D representation of a 3D world that you're able to see because we have binocular vision. So anyways, this is why this stuff gets so complex. There's so many various things to talk about here. So let's get rid of the protractor now. And so now this is our cone of vision. This is the illustration that you'll see a lot of times that people show, and they say, hey, here's your cone of vision, have fun. And it's like, okay, cool, I can see how to maybe work through this diagram, but what really makes it, what makes it work when I go to put a building in here or a car or anything? If I just randomly pick vanishing points, I might get something I like, or I might get an undesirable effect. Now, the thing is that, the neat thing is that since you are creating it, you do tend to just use your eye anyways and judge things that way. I've drawn for many years, and I only recently really understood what we're talking about here. I just utilized my ability to judge error, and if it didn't look right, I started redrawing something. But that can be messy. You could start drawing a scene and then get pretty good way into it and go, wow, these buildings or whatever it is you're constructing just are out of the perspective that I wanted. They just look distorted. So how do we control that? So once we get to this point, just remember the station point down here at the bottom is going to be the part where you map all your angles. Okay, so if you're trying to do that, so for instance, you're still going to use, let's put a ground plane in here. We're going to use that center vanishing point, and if you notice, all these lines converge back to that center vanishing point, right? It's like a 1-point perspective, and everything else is would be vertical or horizontal lines. In this case, just horizontal lines going across like this to give us the illusion of depth. but we're not really after a 1-point perspective here. But you still want to combine the idea that a 1-point perspective, or in this case a CVP, coincides with a 2-point perspective. And let me show you what I mean there. So now as we introduce something else, we'll say a prism, we're going to use a 90-degree angle at the bottom station point. Okay, so what I need you to kind of, I know this is a bit messy and hopefully you'll be able to see this and understand this, but I know that this prism up top here has 90-degree angles because I started off by using the protractor down here at the bottom station point and finding 90 degrees on this. Okay, so whatever I create down here at the station point with a protractor is what I'm going to get up here in my 3D representation of space. So let me show you what I mean there. If I get rid of this protractor and we've got the 90-degree angle right here. So picture, you're looking down at this, right? So this purple line here, this magenta line, you're looking at this. Pay attention to what you see right here. It's pretty evident that that's a 90-degree angle. And maybe it's not, depends on how good you are at gauging angles, but I can see it's a pretty, I know that I use a protractor, so I know it's a 90-degree angle. But what happens is, since I use that to find the LVP and the RVP, left and right vanishing points, I know that now from working from there into this cone of vision, that this is now a 90-degree angle on the edge of this rectangular prism. Okay, so obviously it's hard to gauge there because it's in perspective, but I know it is because I took the steps to create it in the way that it was needed to be created, and that's what you get. So now, for instance, this is often a question I get. How do I rotate? So we found out how to make one prism with a 90-degree angle in a 2-point perspective, but now I want to create another one, but I want to rotate it. Now, if you were to just randomly pick 2 more vanishing points, then random is what you get, right? You might get something adverse to what you're looking for. But if you take a 90-degree angle, again, down here at the station point, and you just rotate it, and then create your next prism, you're going to get another rectangular prism, or whatever you're after, in that 3D perspective. So again, if you look down here at this, the yellow lines, that's a 90-degree angle. Again, why do I know that? Because I used a protractor. That gave me my vanishing points up here, left and right vanishing points, and then I work into my picture plane and my cone of vision to keep, to avoid distortion. So that's essentially how you use these pieces of this puzzle. And I know it can seem confusing. Just do it a couple times, make these examples on your own and practice making different shapes and rotating them by moving these angles. Now, you're not always going to want a 90. Now, a 90-degree angle is obviously, that's buildings and almost everything built starts off, in a block and a 90, and then you have variations of that, but you might specifically want a 45-degree angle, or you might want a 30 or whatever. You're going to do all that. So everything that you do down here at the station point will basically result into what you get inside of your 3-dimensional representation, or in this case a 2D surface that's supposed to resemble a 3-dimensional scene. All right, and I just want to explain real quickly, if you were to do a 3-point perspective, notice that I've got vanishing points on the top left, right, and bottom. The top line in this case is going to represent the horizon line. Obviously, if the triangle was flipped, the horizon line would be at the bottom, and you'd be looking more up at these structures or whatever you're trying to create. So notice that the picture plane is inside of this triangulation of the vanishing points. So in this case, to control distortion, you really just want to work closer and closer inward to this area. So if you want less distortion, now keep in mind, 3-point perspective in and of itself is distortion, so you're going to get some distortion. But notice that as we create prisms on the inside of this, converging to each one of these vanishing points, that basically the boxes or prisms look relatively correct in perspective. But as we start to get on the outside of our picture plane and closer to the edge of these vanishing points, we start to see more distortion. And then once we go outside of this triangulation, we see a lot of distortion. In fact, this is where it's going to start to actually bend the corners to where they don't even look like they're a true structure. They just look warped. So just keep that in mind. This is a very simplistic way to approach the three-point perspective process, but if you put that picture plane inside of here, you're going to be able to control your distortion. But again, you're going to get some look of distortion because the idea is that you're now further away from an object where, like picture a large building, where the bottom of it is now, literally distorting away from your perspective. It's converging to that lower vanishing point, and it's getting smaller and receding into space. So generally you'll reserve three-point perspective for conveying, sheer magnitude and scale, again, like a cityscape or something like that. But also you can use it to add drama to some of your storytelling. So if there's that, thing that you're trying to make more dramatic in a scene, you can do an upshot or downshot or whatever. And again, using a three-point perspective for that really helps to convey that. So at any rate, I'd love to know what you think about this particular video, as well as what you'd like to see in the future. As always, keep drawing, keep having fun, and bye for now.